Hey Brett, this is Will. I just wanted to make a video talking about the math proof that I told you about. Because I'm just really excited. I got the solution like not too long ago, and yeah, I'm just extremely pleased with what I got. I'm pretty sure that this is like out there somewhere. Like it's not a new kind of solution, but I'm happy with it. Um, but yeah, so the problem is prove that the sum of positive integers from 1 to n is equal to this expression right here. So in other words, just to put it into a better notation, I guess, it's that. So what I did was I started with a simpler case. So instead of doing this, I was like, okay, how could I figure out what expression this would be? The sum of 1 to n of n. Like just, or any constant really. And of course that's just going to be n plus dot 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 n, and it's going to be n many times. So it's really just going to be n squared. So I kind of was trying to figure out, instead of starting with this, I didn't really want to start with this. I wanted to start with this, and I wanted to try and like derive that. That was, to me, how I wanted to prove it, because I don't really like starting with the expression first, because I don't know, it feels better when you can actually figure out what it is, and then it just makes more sense to do that. So I tried doing that with a simpler case by just adding a constant together. In this case n, and that's just n squared, so that's the expression that you get from that. And so this gave me the idea of doing it geometrically, because when I saw n squared, I'm like, okay, that's really just a square that's n by n. And as soon as I did this, it actually took me a while to make the connection that, you know, n squared, it can also be thought of as just an actual physical square. So as soon as I drew the square, I was like, okay, wait, can I do that with this sum? And the answer is apparently yes. So what I did was, I'm like, okay, if you're adding together all of the positive integers, then it's kind of like a, let's just do that. It's kind of like building like stacking squares on top of each other, or they can be anything. But essentially, this is when j equals 1. So let me move this over a little bit. So this is when j, or I think I used I. This is when I equals 1. And then when I equals 2, your sum is going to be 3. And, you know, all the way up to n. Like that. And your sum is going to be something. And really, this is just, it turns out that this is just a triangle, because a right triangle with equal base and height. So it should really look like this. So you'll have your n there, your n there, and then you'll have something that looks like this. And this just like absolutely like blew my mind. I was so happy when I got to this point, because at this point all you have to do is consider this a triangle of n by n. And so if you do that and you get the area of that triangle, then you've essentially got your answer, because these are all of the these are all of the integers that you're adding together. So like this is 1, this is 2, this is 3, this is 4, and so on. And so if you got the area of the triangle, you'd really just be getting it from we'd be getting the value from just the inside of this. So obviously that's, you probably already know exactly what I'm doing by now, but so this is just 1/2 n squared, so n squared over 2. And then we have to add the area that's unaccounted for, that's outside of the triangle, which is, you know, this stuff. Yellow's a bad color for that. Yeah, just all this stuff. And all of this stuff is obviously just exactly half of the little squares. So it's their total area together, summed together, is just going to be, well, we have n many of them, because n is the vertical that determines how high the triangle is. And it's just going to be half of that, so it's just going to be n over 2. So it's really just all this area plus n over 2. And if you simplify that, that's n squared plus n over 2. And I guess if you simplify it even further by factoring the n, then you get n times n plus 1 over 2. And I'm just so satisfied with this. I thought that was so cool, that you can visualize it like that. And it also made me wonder what other kinds of sums that you can visualize geometrically like this, and what kind of shapes could you get. Like, it's, I don't know. I'm still like experimenting. I tried the same thing with all of the even numbers, so summing all of the even numbers together. So like from I equals 1 to n, sum to n, what would that look like? And it's really just like the same thing as this, but we're just kind of scaling each, you know, unit block. So it really should just look something like, it could either look something like this, like this, and just kind of split it into, you know, like that. Or, I mean, it could look like this. It really doesn't matter. It's the same thing. It's just different ways of, Oh, yeah, this is what I meant to do. Yeah, it doesn't matter. They're all the same thing. It doesn't matter how you break it up, really. But, yeah, I'm trying to figure out, like, what other kinds of shapes can you make besides, like, squares or rectangles or triangles. I think if the number that you're summing together is constant, meaning that it's, well, I shouldn't say constant, but linear, maybe, then it'll always be some kind of form of rectangle or square, or half of a rectangle or square. But if it's not linear, I feel like it might be different. I haven't tried it yet. But yeah, that's it. That's all I wanted to share. I think that's really cool. So yeah, I'd like to get some of your input on that. So thanks for hearing me out.